Okay, so for this video, we're going to be looking at the trapezium rule. The trapezium rule is used to find the area on the graph when the equation itself is quite difficult to integrate. Because we've learned all the different integration methods by now, but sometimes in the A-level curriculum, you might not be able to integrate more difficult integration questions, so we can use the trapezium rule to estimate the area on the graph. As I said, it's an estimation, so I'm not going to give the exact value, so we're going to look at how to calculate the area later on in this video. So first things first, I've written out the trapezium rule for you guys here. A couple of things to notice is, or point out is, first of all, this h. H is b minus a over n. B being the last x value, a being the first x value. So what I mean by that is, in the trapezium rule, what you would have to create yourself, or they might give it to you, is a table where we have x and y values. And in between, we're going to have a couple of x values and their respective y values. So a will be the first x value, b will be the last x value. This n represents the number of strips, and this will be given to you by the exam or the question, or you might have to work out using a table. So they might say, oh, it's 4 strips or 5 strips or 2 strips. So they'll tell you. If they don't tell you, then and they give you this table, well, the number of strips is actually the number. You can think of it as a number of lines inside the table, excluding the outer ones. So what I mean by that is this 1, 2, 3, 4. In this case, it's a 4-strip table. Okay. Then looking at the equation itself, as you can see, apart from the first y value, it says y0. This represents the first y value here, y0, and yn represents the last one, yn. The rest of the y values are inside this bracket, and we sum them up, and then we multiply it by 2. So excluding the first one and the last one, the rest are inside the bracket, and we multiply it by 2. And then it's just a matter of using this equation to get the estimation of the area. Right. How to get where this equation comes from, the proof of it is not really necessary. It's not necessary at all for the A-level curriculum. But I'm just going to show you it's very simply, just in case if you're curious. If not, you can skip ahead to the part where we're going to do the example. So it's called a trapezium rule for a reason. So if I was to draw a trapezium like this, I'm going to draw another trapezium and one more like so. And I'm going to label each side, let's call this A, B, C, D. And then this length, I'm going to H, so they're all H's. So we know the area is just, we know the area equation for a trapezium. So in the first one here, the area will be A plus B divided by 2 multiplied by height. The second one will be B plus C divided by 2 multiplied by height. And the third one will be C plus D divided by 2 multiplied by height. And so to get the total area is just the sum of each one, right? So it's going to be A plus B divided by 2 plus so this is the total area of the trapeziums. I can now factorize it taking h over 2 out, and I'll left with A plus B plus B plus C plus C plus D. And as you can see, we have 2 B's and 2 C's, so I can rewrite that as A plus 2 times B plus C plus D. And this should seem very familiar to you guys, because as you can see, it's the same form as the one we just written below, or the equation above here. You can see that if this is y0 would be our A, yn would be our D, and the rest will be the B plus C values like this, multiplied by 2. So as I said, this proof is not necessary for A-level, it's just to show you where it comes from. Right, so let's move on to an example. So let's look at this one here. So you can see the diagram shows the curve with the equation y is x minus 2 ln x plus 1. And they're asking us to find the area. So as you can see, they've given us a table already. So all we need to do is find the remaining y values. So just simply plugging it in. So the first one will be y is equal to 2 minus 2 ln 2 plus 1, which is just 1. The second one is the same thing, 2.5 minus 2 ln 2.5 plus 1 will give us 1.4581. Okay, so now it's just a matter of using the equation. But before that, we need to find what our h is. So h is b minus a over n. B being the last value, which is 3. A being the first one, which is 1 divided by n. They haven't told us the number of strips, but in that case, what we do, we look at the table itself and we count. So we have 1, 2, 3, 4. So it's going to be 3 minus 1 over 4, which is 1 over 2. Just to check if the h value is correct, is the h value should correspond to the difference between the x values. So as you can see, we're increasing x's by 0.5, our h is 0.5, so we know it's correct. Now it's just a matter of plugging into the equation. So a is equal to 1 over 2 times the height, which is also 1 over 2, open bracket. The first y value, y0 is 1, plus 2 times the rest of the y values, so the 3 here, which will give us 0.7971 plus 1 plus 1.4581, plus the last y value, which is 2.0986. And then you just plug into a calculator to get 2.402, like this. So actually using the equation is not too difficult. It's just make sure you get the right y values and make sure you get the correct h equation. It's very important in the exam that you actually show finding out the h equation separately rather than skipping straight to here, because then it's just like a working out mark. And that's it for the trapezium rule. When actually doing this, there are a couple of like 1 mark questions which the examiners could give you, which could maybe trick you up. So popular 1 mark questions are, is it an underestimate or is it an overestimate? Because as we said, the trapezium rule is an estimate, right? So it's not going to be the exact value. So it's going to be an underestimate if the graph itself is a convex graph. And it's going to be an overestimate if the graph itself is a concave graph. Okay, convex being a graph that looks something like this, and concave being a graph that looks something like this. Okay, that's the first 1 mark question that I could give you. A second one is, how do we increase the accuracy? How do we increase the accuracy? Okay, and the way we increase it is by increasing the number of strips. So strips being the n value, right? So if we increase the strip number, then we will also increase the accuracy. So those are the 2 1 mark questions which they could give you. So just be aware of those when actually taking the exam.